Hey, our next goal is to make the transaction pool maps sync up when new peers are started. Luckily, we have a pattern for that in place. Right now, we have a method called sync chains, which synchronizes the blockchain data on startup. So right at the bottom, let's take advantage of this existing pattern by refactoring this method to a more generic one called sync with root state. Cool. Now it can still make the request to sync for the API blocks. But in addition, let's make a second step, which also uses a transaction pool map get request to also sync the root transaction pool map with the new peer. So this takes a URL, and similarly, we're going to want to use the root node address. So we have root node address, and we want to hit API/transaction pool map. Cool. Now the second parameter to this is a callback function, just like above, which has an error, response, and body field. Very nice. Now, as long as there's not an error and the response status code is 200, we can continue with the response. So we have no error, and we want to make sure that the response status code is representative of a successful request, which we do by making sure it's equal to 200. Then let's set a variable for the root transaction pool map that is the result of calling json.parse on the return body from the request. Nice. And just like above, we're going to have another replace log. So we're going to say that we're replacing the transaction pool map on a sync with, and then as the second parameter, let's add in the root transaction pool map. All right, nice. Finally, we're going to want to set this entire transaction pool map as the new transaction pool map data for the pool itself. To do this, we're going to add a new method to the transaction pool called setMap. And as a parameter, this is going to take the entire map data that we're getting as the response from the root node. All right, cool. So we're going to need to implement this setMap method next. However, notice that sync with root state isn't called anymore because we're still referring it as sync chains in the app.listen callback. So we need to call sync with root state. Once you have that change, as well as the new request to the transaction pool map, go ahead to the transaction pool.js file itself, and we should add that setMap method. Now it feels like it should go after the setTransaction method, and the argument to this is going to be an entire transaction pool map parameter. And with that entire transaction pool map, and actually let's call this transaction map for short, we're going to set the local transaction map to the incoming transaction map. And in this case, we can trust that the local transaction map is going to be just fine because this transaction map argument is coming from the root node's value. Cool. So overall, this should make the code that will sync up the transaction pools for a new peer when it gets started up. Let's go ahead and test this out. In the command line now, let's fire up a main instance of the application with an npm run dev, and then on a second tab or a new window of the command line, let's fire up a peer. And as we do so, it says replace transaction pool map on a sync. Very cool. So it's going to sync up with that local empty transaction pool map. However, that's not as exciting as seeing an actual transaction pool map sync with some actual transactions within it. So what you can do is go to Postman and post a couple transactions with the API/transact method on the root node. So make sure you have API/transact configured for a post request on localhost 3000, and that the body is correct with a valid recipient and amount, specified with double quotes since this is JSON. Go ahead and send that. The transaction should be successful. And now when we set up, or rather start up that second peer, it'll still say replace transaction pool map on a sync, but then this time there's much more data that it's syncing up with. All right, very nice. So that about wraps up the functionality for the transaction pool. And at this point, we've come pretty far. We've built out the blockchain class, the wallet class, the transaction objects, and now this transaction pool map. Furthermore, we have a network implementation through a pub sub pattern that allows real-time messaging between the nodes in our application. So the next step is to take these concepts even further. To truly make a cryptocurrency, these transactions should be recorded within the blockchain as actual data. So this is where mining transactions will come in. When a node wants to add a new block to the chain, they're going to use the current data in the transaction pool for that new block. Now, they'll still have to pay the computational power to find a valid hash, which is why there's that analogy of it being mining to add a block. But as a reward for the work, the blockchain will do a special transaction to award some currency to the miner. So that's the essential idea. Beyond that, there's going to be extra nuance, like only getting valid transactions and properly clearing the transaction pool across the network when mining happens. So let's work on this final piece of the cryptocurrency next.